Hello my fellow mathematicians. Today we are going to be learning how to calculate the arc length of different parts of the circle, so of each sector, according to the fraction of a circle that it makes up. So by the fraction, hopefully you know one revolution in a circle is 360 degrees. If I'm going to find the arc length of a sector, I need to know either how many degrees or what fraction of a circle it is. So how many degrees will give me a fraction, but if I can just see it like I can with these ones, I can skip this fraction bit. So one thing I really want you to notice is that the arc length is just the fraction of a circle times pi times the distance. So this part here is the normal circumference calculation. So all you are doing is multiplying by the fraction of a circle. Now that's really important because all I need to know then is the angle, or in this case, can you see this is half a circle? This one here is a third of a circle. Here I've got 1/4 of a circle, and if you have a look at this is actually, that would be 90 degrees, so the arc length for that would be 3/4 of a circle. So these would be half times pi d, because I know the diameter. This would be times 2 pi r, because I know the radius, times 2 pi r, because I know the radius, and this would be times 2 pi r, because again I know the radius. So when it comes to fraction of a circle, that you can see, you can go quickly into that. But here we're going to write down what we know. So I'm going to be looking at this sector here. Write down what we know. I know that the angle, and that's just what that little bit there means, angle is 120 degrees. Make sure you read the question because it can sometimes say the major sector or the minor sector. So my radius is 6 centimeters, so we write down what we know. Now we'll write the rule for that. So my arc length equals angle over 360. I highly recommend you write it every time, because that way you will remember it. Now I'm going to sub the values, so I'll just write it out until I have to sub the values. So I'm going to sub the values. Theta, so this angle is 120, and radius is 6. So I really encourage you to do that, as in write out what you know, because then it's easier to sub the values. Now you just put that in your calculator. So you put it in your calculator. You can put brackets if you want, it really doesn't matter. So 120 divided by 360 times 2 pi r is 4 pi. That's the exact value, or you can just press 12.56. Well, we'll go to one decimal place, so that will make it 12.6, because 5, 6, the 6 rounds it up to the 5. And don't forget your units, centimeters. Now, that is only that distance there. For me to find the perimeter, I have to add the 2 6s. Often forgotten. So with this, it's going to be, so your actual perimeter equals the arc length plus 2r, which is 12.6 plus 2 times 6, which is 12. So it's going to be 24.6 centimeters. Now we're going to look at another problem, which is this example 2. If you have a look at this, you need to notice that that's a nice little diagram, but you need to read the question. So just to make sure that you are reading the question properly, it says find the minor arc length. So this distance around the red line is actually the major arc length because it's the biggest one. The distance around the outside is actually the minor arc length. All right, so for us to be able to calculate this, we know the major angle, but we have to work this angle out here first. So for us to be able to do that, you need to know that the full revolution of a circle is 360 degrees. So that's what you need to know. So in your book, you'll write theta, which is the angle, is 360 minus 230, and you will get 130 degrees. So the angle that we are trying to find, or the arc length, corresponds to the angle of 130 degrees. So then we have to write down the radius, because at the moment we're writing down what we know. So the radius is 3 meters. I'm after the minus sector. So now I just write the rule that corresponds. So I don't sub values yet because I'm trying to make sure I set myself up for success. You can go straight into writing it. I'm just doing a different color so you can see that I've subbed the values. So theta equals 130 degrees, so that's what the angle equals, and the radius is 3 meters. Then you put that in your calculator. So I've put it in my calculator and I've got the exact value, so I just change it to that. 6.8006, blah, 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 which is about 6.8. Now the units is meters. So this is the arc length. So now I need the perimeter, which equals the arc length plus 2 times the radius. So we've got 6.8 plus 2 times 3, which is 6. So now we get 12.8 meters. I hope this will help with your calculations.